Hi everyone, welcome back. Today we are solving apple redistribution into boxes. So we will be given an array of apples and also an array of boxes. And in the arrays, each apple and box will have their own size. And our goal is to put all the apples into all the boxes. And we want to return the minimum number of boxes that we can select to redistribute the packs of apples into boxes. So if we look at this example, we can distribute 3 and 2 into the box of size 5 and 1 to the box of size 4. So that's why we return 2. And if we look at this example, we can put all 5 in the box with 7, and we can put 2 remaining in this one, and which means we have 3 more from this apple. So then we can put 3 in size 4, and then we have to grab 1, put it there, and now we have 4 left, and we can split it and put 2 in this box and 2 in this box. So that's how we return 4. So now that we have seen some examples, let's get to how we can solve this problem. So to minimize the number of boxes we will need, it is always best to put the largest boxes in the front first, or in other words, use the largest box first. So what we can do is we can sort this capacity array with the largest ones in the front, and then we can set total to the sum of the apple array, and then we can iterate through the capacity array, and as we iterate through, we will subtract the sum from whatever is at capacity, and each time we iterate, we increment result by 1, and as soon as total is less than or equal to 0, then we can return the result. So let's go over this example real quick. So first we sort the array and set the total to 6, and now we can iterate. So 6 minus 5 is 1, increment result by 1. Now 1 minus 4 is negative 3, and increment result by 1 again. And now that total is less than or equal to 0, we can return this as our result, meaning that we will only need 2 boxes from capacity. And the time complexity will be O of n log n, where n is the number of boxes in capacity and m is the number of items in apple, because it will take m time to calculate the sum, and it will take n log n time to sort this capacity array. And the space complexity would depend on what sorting algorithm you use. But for the Python sorting algorithm, it would be O of n to sort this capacity. So that's why it will be O n for my example. So now let's get to the coding part. So first we can set the total to the sum of apple. Then we can sort the input capacity array and make sure we set it to reverse because we want the largest at the front. Now we can initialize result to 0 and set the while loop as while total is greater than 0, and we can subtract total to the capacity of result and use result as an index, increment result by 1, and return result at the end. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave in the comment section, and I hope to see you all again soon.